Thomas Ergin will be talking about a very catchy topic, precise ABAP. I'm very interested to see what he'll talk about, and maybe just to give you a little bit background about Thomas. Thomas is a true techie at heart. He's a true techie. For example, what he do is anything and everything that he sees, he thinks about the technical attributes or aspects behind it. You'd see probably a spoon, a spoon that you use to eat, and start thinking about its spherical dimensions, how it's designed to fit nicely into your mouth, and how it's also designed to land at a perfect angle on your tongue so that it can have a perfect effect on your palate. This is Thomas. Everything that he sees, he thinks and analyzes the technicalities behind it. Thomas, if you are ready, you can take over the screen and start with the talk. Thank you.
You're able to see my screen right now. Okay, thank you for this really nice introduction. I hope that I can feed you a spoonful of software engineering today. Welcome to Precise ABAP. In the next half an hour or something, you are going to experience a few drawings on spacecraft and perhaps a few words on ABAP software development. My name is Thomas Ergin. I'm a software developer for 30 years, and I'm doing ABAP software development for more than 20 years. My focus areas are software quality, application architecture, operational excellence, and I think I know a few things about solutions that work well and solutions that might kill your system. Today, I'd like to give you several of those recommendations for writing ABAP in a stable, resource-efficient, and concise way. But let me start with a few words on clean code, because I mentioned that in the agenda for this talk. Okay, most of you should at least heard the term of clean code, and ideally, most of you are already following those principles that has been defined by Robert C. Martin in his famous book on software development. Basically, if you haven't read the book, it's about telling a story. You should write code that it is not just understood by a computer, but by an actual human being. So instead of taking all these strange abbreviations that SAP is full of, and all these kind of things that make sense for an ABAP developer, instead of that, clean code means write code in a way that it's obvious what you are doing here, that every line is concise, every line tells you something, and everything makes perfect sense in a way that you can easily track an error and explain the code to someone else. But while writing readable code is already great, there are more aspects that are relevant for software developers. Things like having your code lines in a proper sequence, or being stingy with your code, like not using many lines when you could only use one line for that. Being resource efficient and being resilient, because you want your solution to be available perhaps 24/7, not fail it all over the time. What I described as precise ABAP takes the concept of clean code a bit further, with a focus on the little aspects of SAP developers' everyday problems. Just a few words on what I see as relevant for us developers. So, precise ABAP developers look beyond the ABAP system. The thing is, SAP has a vast zoo of technologies, but most of these technologies are lagging behind the software mainstream. Since, for example, Object orientation has been created something around 1916 and has been introduced to SAP or to ABAP around 1999 or something. So like 40 years later. Or other aspects of software engineering, like framework-oriented software development or functional development. HTTP web standards has been introduced with other developers, because likely problems that you might want to solve with SAP, with ABAP, has already been solved outside of the SAP world. Next. Leverage existing library functions. Please do not create anything that is generic. If you see something that where you think, oh, this is most likely already implemented by someone, like functions about date, time, parsing, rendering, all these kinds of like file access, creating document format. Most likely, there's already a library function for that. The SAP did great with the recent not too long ago introduced XCO library that added a lot of functionality to modern SAP systems. Usually, I spend more time in searching for repository objects and library functions than building my own code. This is even more. Do not write these generic things that I mentioned, like do not write parsers and renders. Because your problem is specific, but usually the parts of the solution will be used, can be used many times later. So build a solution, design a solution with reusability in your mind. Think about the next customer, think about the next project, the next department that also want to have that same solution. The Git and ABAP Git took that thing further. We have a technology now that we can easily share our ideas, our concepts, our solutions all over the internet with each other. I think it would be really great that open source gets to the next level in the SAP. And now, something that is really important for me, do not maintain a clean and an unclean style. I've seen that so many times. A developer does something in a hurry and says, okay, this is something that I just did as a prototype. And later I'm going to do that in a clean way. But in that very moment, you do not train your clean style. You are more likely not to use it when it's important. So do not differentiate between clean and unclean. The same applies, by the way, for performant and unperformant. Oh, this is something that I did in a hurry. There's a good saying that says everything that is a temporary fix is permanent. So in that moment, you produce a solution that is fragile, that is resource exhausting. There's a good chance that you do not find the time for fixing it in a way that it makes sense later. And you are going to deploy that fragile thing and it breaks to the usually least pleasant time. And you need to distract from whatever you are doing and focus on this broken thing of yours. But now about the warm words, let's have a look at the code. Sequencing. Instead of starting your method call with a validation, do the validation up front. This prevents the accidental execution of code that is not supposed to be executed, such as retrieving logs, opening connections, or doing something that is time-consuming. And furthermore, your code becomes more concise, and you can see immediately if a specific error condition has been dealt with. If you go it the other way around, like do your business code first and then do the error handling later, you might miss that. And it's not obvious to other developers that you dealt with that. Furthermore, refactoring gets much easier with the code on the right side. Next, sequencing. Here again, do your validations at the very beginning of your method and as part of the method, instead of having it as part of in the calling phase. By that, the validation is always carried out when your message is invoked, instead of that the developer who might reuse your method need to copy not only the execution, but also the validation and add it to the code. This is especially important for authorization checks, because authorization checks should assure that nobody unauthorized execute the business code protected by this authorization object. If you have the check not at the very beginning, but somewhere else in your application, somewhere during a later phase of the refactoring, it might happen that somebody accesses the code that he is not allowed to. More about sequencing. Do the expensive things last. If you have two methods and the order does not really play a role here, like I am going to read a huge data source and a small data source, for example, that provides customizing, then I would recommend to use the fast one first. The reason for that is if the first method already fails, it's not necessary, it might not be necessary to execute the second lengthy one. So your application might stop in that very moment. The first fast thing fails, and it does not waste more resources on performing whatever the slow method does, like reading huge data amounts from a remote connection, reading the database, calculating things, and then throwing it away because the second method failed. And something that you should really do, if you are not doing that, of course, already, use the inline declaration as much as possible. This is not only clean code, this is so concise, it's so helpful, it's so stable. In that very moment, you declare your variable instead of upfront, but as part of your method call. It gets the definition, or the variable gets the type of whatever your method returns. And if you later want to refactor your method and change the signature, your variable is changed as well. In the left example, on the left side, you always need to make sure that when changing the parameter signature of your method, you also need to adjust the variables themselves. One more thing about signatures. My recommendation is also to keep signatures as slim as possible. So first, use a small number of parameters. And next, also restrict the types of parameters that you are using. Ideally, you are going to follow the functional paradigm. This means you're not using changing parameters, you're not using exporting parameters in your method as part of your method, but instead you have 0 to many importing parameters and up to 1 returning parameter. The cool thing is if you follow this paradigm, you can use this functional call wherever you would use a variable. So you could chain your executions. You do not need to take care about clearing variables upfront because the returning variable is always cleared by default. And your code will be way more structured and readable than if you are using, for example, changing parameters where a developer would always need to understand which part of the parameter is now changed, which part of the parameter is now used for further processing. Usually, having a large number of parameters is a hint that you either violated the separation of duties concept, which is elementary to software development, or the keep it simple principle. Because this means usually your method is doing many things at once, instead of just reading or updating or locking or opening a connection. It does like 5, 6, 7 things at the same time, which is often something that you try to avoid when talking about things like separation of concerns. Error handling. Exceptions should stay exceptional. Do not use an exception for something that can happen all the time. For example, in my example, locking, if you request a lock, it can easily happen that someone else or some other user already locked that very document. This is nothing unusual. This can happen all the time. Raising a lock in that situation, it's the wrong message. First of all, you're sending the wrong statement to other developers reading the code, because they say, oh, this is something exceptional, this shouldn't happen, while it's something that is common. Furthermore, working with exceptions, even if it's quite fast, it's still slower than just returning a message or returning a Boolean variable, because you need to retrieve the call stack, you need to process messages in a way, just add some amount of the memory to your application, so it sums up. So your application gets a tiny bit slower doing that unnecessarily. Rather a dump than an undefined application. I know this might steer a controversy, because usually your application shouldn't dump. This is not a good thing at all. I do not want to make advertisement for short dumps, because they also stop the system or the work process where your application is running on for a while. It takes resources, it takes storage from your system. You do not want to have short dumps. But there are certain things that should really not happen. For example, here I gave like retrieving a GUID from your system. I have no idea what could lead to that my system does not provide a GUID at all. If something like that happens, your system is in a completely unusable status, and you do not want to continue here by packing it into an exception and then moving on and hoping everything gets better later. The same applies for something like if your general customizing is missing. Of course, you can provide it to the user. Customizing is missing. Ask your administrator or something. But it might be even safer to say, okay, stop that application in that very moment where this really bad thing that never should happen still occurs, because in that very moment you get immediately a response that something is wrong with your system in a way, or with your application that has never been catered for in your application. So again, this does not mean that a good dump is a good thing, but it might be a better thing than just catching, especially with the to be done that some of you might know, and then carrying on. Enable the where use list. The where use list is still something that is pretty cool. You can easily find who used what BAPI or what message type or which class, which method, whatever object you can think of. You can find it in an easy way with where use list. In that very moment, you write something generic, like on the left side, something went wrong. An error occurred, status X happened, or something like that. you eliminate the chance that a developer who experiences that problem easily finds out the source where the problem might come from. So instead of writing something generic, think of having something that enables a very use list. For example, here I use a fixed message type. You might want to define your own message type or anything else that allows others who are faced with that kind of problem to carry on and find out, spot the exact part of the code where the error occurs. Same applies, by the way, for generic messages. SAP is full of those things, like you have a message that is just a placeholder and you can feed any kind of message into that. And these things might be called 10, 20, 100 of times in your application as part of the framework that is used, as part of the library function that is used. Instead of that, use as specific as possible method, because again, you are able to track it when the error occurs while your application is running. Talking about a bit about resilience, because I know that resilience, with software resilience, you can have a full session only showing and discussing different resilience patterns. I just want to name 3 important patterns that you should know, and most of you are likely aware of, but that help you, especially when you work with distributed computing, when you work with parallel processing, when you work with remote calls, either RC or HTTP. So working with distributed solutions where your SAP solution system might be connected to other subsystems or even non-subsystems, then sooner or later you have RC calls or HTTP calls or HTTP over RC, and these connections can fail. The number one fallacy of distributed computing is the network is always reliable. Spoiler, it is not. So a connection might time out, it might be slow, it might be on off. So instead of just issuing the HTTP message or the RC call, of course, you might want to have something that tries a few times the connection before it goes back to the user and tells them, oh, system does not respond. Usually you want to do something like 2, 3, 4 times before you stop the application, because the network sometimes it has a hiccup, and immediately stopping your application just because of the hiccup, you don't want to do. Even better if you combine that with a timeout, because just repeating something over and over again takes a bit away it reduces the control of the runtime for your application, because you don't know how often the retry might last. Because sometimes you open a connection and the system tries to send something for a few seconds or even longer and tries to establish the connection, and the connection is not going to be opened, and sub will wait and wait till it drops. And if you do that sometimes, like if you repeat that a few times, then your application already is stopped for that amount of time. And if you're doing that many times in parallel, like if you're doing parallel processing, many work processes will be waiting at the same time for a response that does not come back because this remote system is down. In that very moment, it could make sense to have a timeout that says instead of trying it like 3 times, try it 3 times, but up to 5 seconds, for example, or whatever threshold you can is suitable for your solution. Taking this concept even further, it is the circuit breaker pattern, which is a cool thing, especially if you want to do the same thing many, many times at the same time. In cloud-based solutions, in distributed solutions, you often have, like, you want to send hundreds or thousand messages in a really short time, and you utilize multiple work processes for that because you do not want to wait for hours till all the messages have been sent. In that moment, you do that, and you put all these methods into different work processes, and the connection to the remote system fails. All the work processes might be pending, and might be waiting for RC or HTTP response. And this utilizes many work processes that don't want to do, because the system the number of work processes is important resource. If the number of free work processes in your system falls under a certain threshold, the users will suffer from that. Your system might even trip. I've seen many subsystems failing because they were out of work processes. So the circuit breaker abstracts this connection handling in a way that instead of your application, the application that you have directly contacts the remote destination, it will ask the circuit breaker, is a connection open? Is a remote system available? If yes, then please send the message. If not, then I'm going to wait till the circuit breaker will be opened again. And the circuit breaker will check from time to time if the connection is open, or if the connection can be established. And if not, it will tell all applications asking for a connection that the connection cannot be established. This is a cool pattern and that you want to look into. Another easy resilience pattern that you should know is, of course, a fallback. Instead of relying that a certain thing is given, provide an easy mechanism, like in this example, a default value, where your application can continue. The user has not set any a language for himself. Okay, then continue in English. This is nothing complicated. But you need to consider it when you build your application, that this fallback mechanism could make sense. What I really like is implicit coding. Instead of using many instructions to build and tell the application what it should do, use those things that are already given by the compiler. And you know many of those things. For example, ABAP, if you define a variable, it's clear by default. So you do not need to clear it because it's done implicitly. Another thing that you should know, that you should regard, you should avoid the statement if whenever possible. If itself as a statement, it's not a bad thing. And you might use it in many, many applications. But every time you introduce an if, your application gets a bit more difficult. You are opening at least two different branches in the execution flow where both need to be tested. If you have two ifs after each other, you might already have four different application flows where you might need to build unit tests for things that you need to cater and think of. So ideally, you find an execution path that goes along without using it. For example, here, I just do whatever I want to do on all my customers from South Africa, instead of checking if I have a customer from South Africa. Similar thing with commit and rollback. Usually, I've said several times, if you see commit or rollback inside of another solution, in 4 out of 5 cases, it's usually wrong, because the developer does not really know like how the logical unit of work works, and if he can commit and work, or if you should call the BAPI that commits. So instead of explicitly committing or rolling back, use the implicit version. For example, in most scenarios, if you trigger an error message or an abort message, commit rollback will be triggered. In that very moment, your transaction ends, your front end has a round trip, an implicit commit will be triggered. So you do not need to do those things that usually create more problems than they actually solve. Try to live without these things. Another thing on implicit coding, don't clear unassigned. Usually these things are superfluous. Again, try to find a code, try to build a solution that goes without those. Because if you have a clear as part of your code, this means you are reusing a variable, which is usually already a bad thing because parts of the variable might still be filled from the first run. Instead of that, you might want to have different variables for different types or for different operations. Often clears mean you have a way too lengthy code where you need to clear in between. So instead of that, solve that with refactoring. Modularization is a good thing. Of course, like is a really nice thing too. Do not define explicit data types, because by that you create a hidden conflict between the variable and the place where the variable is used. Instead of that, have the variable of the same type that you're planning to use. I've mentioned earlier on the inline declaration. Like is also a cool thing. You can say, I want that variable to have the same type of that thing that I'm going to put into that. Instead of saying, okay, this is a fixed time. And later the developer changes the type of the variable and your code breaks. Modularize early. As a rule of thumb, if you have two similar lines inside your code in different places, you should consider to create a method for that. Do not waste lines by adding the same thing over and over again. This makes this makes also difficult to read what you're doing. And more likely, if you are going to change the code later, then you have to add that at multiple places. So if even small portions of code, I would recommend to modularize. Just something about, okay, okay. Same here, do not repeat yourself. If you do not want to modularize for some reason, because you think it fits better in one method, then at least do not the same thing again. Just find a pattern like that, this one that I showed here, that I've given here, that just repeats whatever you are doing 2 or 3 times. Okay. The third thing on code noise, focus on the functions. For a reader of your solution, it should be clear whatever method, whatever module is doing. It should be right on top. In that moment, you create all this boilerplate, all these mappings, all these exception handling, all these error handling, all these other things. You distract the reader from whatever you are doing. All these things that I mentioned, like the mapping, the boilerplate, put it into the lowest method that you can think of, or to hide it away. The more important your method is, the higher it is sitting in the call stack, or if you have an ABAP debugger, then it's sitting low in the call stack, then those entry methods should be concise and to the point, where you can easily see set up, read the customizing, open the connection, whatever it's doing. And all the other things, all these helper methods that is doing the boilerplate, the mapping, will be high in the ABAP call stack. Okay. This is not really about code, but these are a few things about frameworks and library. I think most of you could know these things. If you are using one of those on the left, there are new things for that. Please do no longer use them. All these functions, all these library functions, all these Barbies, most of them, or many of them, have been replaced by something class-based, which is not only fancy, but usually those class-based library functions are more powerful, optimized. They might introduce a buffering feature. They might be usable in an easier way that they are following because they are might be using the functional paradigm I mentioned earlier. RFC, TRFC, QRFC has been replaced by GRFC, by BGRFC. Do no longer use QRFC or TRFC. They are deprecated. Do not use the SPBT framework that has been used in the past for parallelization. There's a really cool way for doing parallelization with newer SAP releases, which is way more stable, way easier to implement, way cooler than this old thing, like with get the number of work processes and do some math and try to assume if you still can fire off more work processes. I've seen so many applications failing because the developer didn't do parallelization in a correct way. But with the CL ABAP parallel framework, it's so much easier to do parallelization. Please use that. Same for the application logger and the number range framework. I mean, okay, some of you might shake your head because this is not really, it seems really obvious. I mean, Eclipse ADT has been around for, Thomas Hitler will tell us 15 years, something like that, or even longer. But I know that many developers still use outdated tools like the ABAP Workbench. If you do so, it's not just that it does not look that nice, but you cannot use cool new features like the really great ABAP Cleaner, an open source project that you will find in the GitHub that incredibly does well with cleaning up your ABAP. When you use Eclipse ADT, you can use the code. You can use cool features for refactoring. The set feature that has been introduced by Thomas Fiedler, I think one at the beginning of this year. If you want to share code with other SAP platforms, with other solutions, with other customers, then of course you shouldn't use cross transports, but use ABAP Git, which is a really great solution for collaboratively working on SAP projects. And you should definitely look into the CodePal, which is an addition to the ATC, which also gives you a lot of improvements or additional checks for finding flaws and issues in your code. So let's have a short roundup here. One for the road. I think it's about the little things. You can't have a great, complex, expensive machine that made of fragile, bad parts and expected to work in a good way, in a stable way. So pay attention also to the small part, those things that I just mentioned to you, where I say, oh yeah, okay, I heard about that, or but this other thing also works, of course. Usually you have 3 or 4, many ways to do the same thing, but usually there's something like the shortest, the ideal, the most performant way of doing things. This is my best advice that I can give to you, your best line of code is a line never written. Although I like writing ABAP, although I'm a passionate software developer, usually the best solutions that I know where I've been involved in were something that has only a small, really small portion of ABAP, or perhaps no ABAP at all, because everything has been done with library, with framework, with everything that the SAP gave for us and where you already have paid for. So do not invent things that are already out there. Have things as short as possible, because also another aspect here is every line increases that of course that you write increases the technical depth. Everything wants to be refactored sooner or later. Everything what needs to be checked, reviewed, tested. So be as short as possible with your code. Be stingy with your code. Trust to your gut, but only for the bad feeling. If you think something might not work, then it will not work. If you're not 100% happy with your code, if you do not really understand all the side effects that come from that library function, then most likely you didn't cater for all the errors that this library function or this framework can produce. And then it's only a matter of time till your application will break. So make sure that you cater for all the aspects that you really understood what that line of code or that framework function does. Yes, do not waste system resources. I mean, usually we are not, as a developer, we are not responsible for those things. Hardware and servers and RAM, these are infinite resources where the basis team take care of. But usually it's not really the truth. Like our subsystem need to maintain multiple applications at the same time. And if you are wasteful with the resources, sooner or later you will run into problems. Even if you say, this application, this only runs once a day, you don't know how your users will change their behavior over time. If the solution is cool, they might run it more often. Instead of running once a day, they might run every minute, 100 times a second, whatever. Especially if you have something like a service, like an HTTP service, a REST service that you expose, you don't know how often this thing will be called. And in that very moment, you are wasteful with your resources. Like you read too much, you do too much, then this might bring your system down to its knees. So build your solution under the idea that it might be running frequently. Even if you are not considering to move your application into the BTP, just check out the ABAP Cloud. Consider using ABAP Cloud as a programming paradigm, because ABAP Cloud is the greatest step that ABAP took for many, many years. It eliminates all the gutter, all these old deprecated malformed statements that you shouldn't be using at all. And ABAP Cloud makes it mandatory to maintain a clean and concise style. So even if you are not having a huge cloud strategy in your company, just consider building your application already cloud ready. This can easily be achieved by just setting the flick in that application object in the source code or in the package or class. And the last thing, which will sound obvious for most of you, avoid toil. Yeah, why should you do that? Of course, I avoid toil all the time. I don't want to have a complicated, time-consuming life. In that very moment, you build, for example, a custom table and do not care about archiving. Sooner or later, the table will fill up and you need to and something bad will happen to your application. In that very moment, you offer a configuration, a customizing option to your user without a validity check. If the user has provided that thing, or if the user provided a valid input to the customizing. Sooner or later, a user might give the wrong input. If you have not considered about adding a unit test to your code, sooner or later, you need to test your application again and again. So by those things, in that very moment, you write the code and you lean back and say, I don't need to do that because it's just a one-time solution. It's not carried out too often. Sooner or later, it will come back to you. And usually it does not come back when you expect it and when you want it and when you can deal with that thing. Usually it comes back when you want to focus on a new application, on a new feature. So try to have a toil-free life by investing early in your application and bringing a precise application to life. Resourceful or with a good usage of the resources, with stable and resilient patterns like defaults, with a good handling of the connections. I've mentioned retry, circuit breaker, and other things, with code in a quality that it makes it easy to understand, to refactor, to explain to someone, and to enjoy it. And that's it from my side. Thank you for listening. Have a great time.
Thank you very much, Thomas. Right on time, right on time. You don't just write precise ABAP, but you also do precise presentations, I see.